Have you ever pondered the intricacies of how objects receive their dependencies in programming? It's akin to a chef in a restaurant kitchen. Imagine if a chef had to grow his own vegetables, raise his own livestock, and churn his own butter. It would be incredibly inefficient, wouldn't it? This is where dependency injection comes in. It's like having a prep team that provides the chef with all the ingredients he needs. Now let's dive a little deeper into this concept. Dependency injection, often abbreviated as DI, is a design pattern in software development where an object receives its dependencies from an external source rather than creating them internally. This object, or class, can be injected through a constructor, a setter function, or an interface. When it comes to dependency injection, there are three main types. First, there's constructor injection, where the dependencies are provided through a class constructor. Second, there's setter injection, where the client exposes a setter method that the injector uses to inject the dependency. And lastly, there's interface injection, where the dependency provides an injector method that will inject the dependency into any client passed to it. Clients must implement an interface that exposes a setter method that accepts the dependency. Such a technique holds numerous benefits. For starters, it reduces the dependency of classes, making your code more reusable and easier to maintain. It also improves the testability of your code by allowing you to replace your dependencies with mock objects. Moreover, it encourages loose coupling and enhances code readability. However, as with any technique, dependency injection is not without its drawbacks. The increased number of dependencies can lead to more complexity and can make the code harder to understand. There's also the issue of over-engineering. When used inappropriately, dependency injection can lead to needless complexity and extra code. It's like using a sledgehammer to crack a nut, overkill for simple scenarios. In conclusion, dependency injection is a powerful tool in a programmer's toolkit. It's like having a sous chef who prepares all the ingredients you need to cook your dish. It can make your code more flexible, testable, and maintainable. But remember, it's a tool, not a magic wand. Used judiciously, it can greatly enhance your coding prowess. But wielded without care, it can turn your code into an unwieldy beast. Today we've journeyed through the concept of dependency injection, its types, benefits, and drawbacks. We've learned how it's akin to a chef being handed his ingredients, ready for use, and how it can make your code more flexible and testable. But we've also seen how it can lead to complexity if not used wisely. So, the next time you find yourself writing code, ponder on this. Would you rather be a chef who has to grow his own ingredients, or a chef who gets handed his ingredients, ready for use? The choice, as always, is yours.